Hey everyone, welcome to class. So, as I said before in the previous video, we're taking a kind of a different turn. Most of the time in math, you look at all the rules and then you do the application at the end. Well, in this one, we're kind of doing the application a little bit early. So the sections are going to be about area, and it does seem a little odd that we're just kind of throwing this in there, but eventually everything will kind of come together and everything will connect. But we got to work through this first. Okay, so we're going to put area on the back burner for a little bit, and we're going to talk about sums. So some of you have seen this before, some of you have not. It's not a big deal if you haven't. So here we go. So the sum of n terms. So we've got all these terms, and we're going to try to add them together. Well, there's a shorthand for that. So that's that sigma, capital sigma, from I equals 1 to n. In here, there's going to be some sort of a function that's going to generate all of your terms. So you can read through this. Note the lower bound, this thing right here, this number doesn't always have to be a 1. So you're going to have two numbers. You're going to have a number down here and the number up top. Just this number is always going to be smaller than that one. So just it doesn't have to start at 1. It could start at 0, it could start at 5, it can start anywhere. So properties of these things, if you look in here inside the sum, if there's a constant times your function, you can pull the constant out, just like you could do with derivatives. And here, if you've got more than one term, then you can sum up each individual term. Okay, so let's go ahead and look at a few, just calculate them. So you're going to sum from I equals 1 to 5 of just I. So you're going to start with a 1, you're going to plug it in for I, and you would get 1. Well, it's the sum of terms, so there's going to be more terms that come out of this. So we started with 1. Well, now you're going to go to the next integer up, so you're going to plug in 2 and plug it into the same function, and you get 2. And you're going to keep doing that until you get to this number up here, and this is your stopping number. So plug in 3, plug in 4, and then plug in 5, and 5 is the last one to get plugged in. And then just add everything up. So 15. And that's how they pretty much all go, and it doesn't matter what the function is, you just start plugging in numbers. Alright, so with this one, let's do the same thing. So we're going to start with 3, so plug in 3. And for the I, so that would make it 6 minus 8, which is negative 2. Now you're going to plug in I equals 4. So that would be 8 minus 8, which is 0. Plug in the 5. So 10 minus 8 is 2. And 5 is the last number to plug in. So you get a total of 0. Alright, part C, same thing, but you gotta watch out. Whatever the variable is down here, that's the variable it goes in for, not for everything. So it's just the k that gets a number in there. So when k is 1, you get x, k is 2, 4x, k is 3, 9x, k is 4, which will be the last number to plug in, 16x, so 30x. All right, let's look at this guy right here, from 1 to 75. Oh. Wow, that's going to be a lot of numbers to plug in, because that'd be like 1 plus 2 squared plus 3 squared plus, and you're going to have to do that all the way up to 75 squared. So you could totally do this by hand. It would just take you a long time to do it. So there has to be a better way. And in fact, there is. So in the next video, we're going to look at the summation formulas and how to shortcut when you got a large sum like this. For smaller ones like these, I usually just sort of just do it because it's just quicker, and then I don't have to remember when anything is. But if you're going to plug in a lot of numbers, you're going to want to use a formula. So in the next video, we'll take a look at those.